All right, so we're going to talk about chapter 2. This is the second time I've done this because I accidentally deleted the last one, so hopefully I do even better this time. So, the first thing we need to do is not forget, but separate the difference between adding and subtracting and those rules and multiplying and dividing. So, when it came to adding and subtracting, okay? When it came to adding and subtracting, when it came to positives and negatives, we just sang the song. Same signs add and keep, different signs subtract. So we sang the song, sing the song, and we needed common denominators for definitely misspelled that. Common denominators for fractions, and we had to line up the decimals for decimals. Okay, so those are some of the add and subtract rules. With multiplying and dividing, it's a lot simpler. So the biggest thing with multiplying and dividing is just one negative number. If one of the numbers is negative, then the answer is negative, or if they are different. If there are two negatives, it's positive. So if they have a different sign, so this would be like, if they have a different sign, then it's going to be negative, and if they have the same sign, it's going to be positive. I don't like to use the different and same because because it starts to sound like same signs add and keep, different signs subtract. So I actually forget these and just remember one negative is negative, two negatives is positive. Three negatives would be negative again. Four negatives would be positive again. So that starts to make sense, especially if you have something like negative 2 raised to the power of 4. Well, that's four negative numbers multiplied together, because this would be negative 2 times negative 2 times negative 2 times negative 2. So the answer would be positive. So that's really the main thing that we need to remember. So if you want to take a screenshot of this, you can, because I'm going to erase it, and we're just going to play with this. So there's probably a faster way to do that. So anyway, we have so this is simple. So when it comes to just regular numbers, regular integers, we just have negative 3 times negative 4. Well, there's two negatives, so the answer is positive, and 3 times 4 is 12. With division, we have negative 64 divided by, actually I'm done with that division symbol, negative 64 divided by 8, so there's one negative, and 64 divided by 8 is 8, and since there's one negative, it is negative. Remember, this line right here, this thing that we've all thought of as a fraction, is the division symbol. If you go to your calculator, the one that the Desmos Scientific calculator is the one I want you guys to use. You'll notice that it does this. If you hit divide, it makes a fraction. Okay, if you put 1/2 divided by 3/4, it does it like that. Because they've realized that the division symbol is just not something that you need to be using anymore. In fact, I would say that this symbol is my least favorite. My second least favorite is the multiplication symbol. I also don't like this symbol because it starts to look like an X, and an X is a variable. So you have to be very careful, especially when you're writing. 3 times 4 gets confusing because we start using X as a variable. So we don't do that. We put 3 times 4 in parentheses, and you notice the reason we know that it is not addition or subtraction is because in between them there's no addition or subtraction. In fact, I could put this would be times negative 4, okay, and the negative sign is in the parentheses, so it is multiplication. Hopefully that makes sense. We're going to keep working on that as we go. I've actually told the 6th grade teachers to stop showing you guys multiplication and division signs. They just confuse you, and it's something you have to relearn. Okay, so hopefully you're understanding the 1 negative is negative, 2 negatives is positive part. Okay, so now there is a portion of this chapter that's important, and that's conversion. Okay, so if I want to convert negative 2 1/4 to a decimal, so we're going fraction to decimal. The way I do it is, it's basically division. So the first thing I need to do is convert this to a mixed number. So this is, if you don't know how to do that, you basically multiply the bottom number times the middle number and then add the top number. So 4 times 2 is 8 plus 1 is 9. So we have negative 9/4. And then we just divide. So first top trap. The first number, the top number, go in the trap, and they also go in your calculator first. So if I wanted to put this into a calculator, the 9 would go in there first. It's the top number, so it goes into the trap. So we do this, and we end up with 2, and that would be 8, which leaves me with 1, and then I have to put a 0.0 and add that and bring down my 0. 4 goes into 10 also 2 times, which would be 8. 10 minus 8 is 2. And now I get to bring down another 0 and get 5. So 2.25 would be how I would convert this to a decimal. So that would have been 20, and we'd be done. No remainder. So 2.25. Negative. Okay. So hopefully that makes sense. Another way of looking at this, actually let's just stick with that. Okay, so the next one is, the next one I wanted to do, it'd be going from a decimal to a fraction. And that would be, let's try negative 0.26. Okay, let's actually make this a little more challenging. Negative 3.26. Okay, so just remember, decimals and fractions, this represents the big number. Okay, if you notice up here, this was our 2, our negative 2. This is the big number. It's on the left side of the decimal. And this 0.25 is 1/4. Okay? So hopefully you guys know those. In fact, like let's do a couple real fast. So 1/4 equals 0.25. Okay? You should know that. 1/2 is equal to 0.5. 3/4 is equal to 0.75, and 4/4 or 5/5 or 100 over 100, anything over itself is equal to 1 whole. Same with 4/4. So actually that would have made more sense to put 4/4. So let's do that. 4/4 is equal to 1.0. Right? It's 1 whole. Anything over itself equals 1. Let's get back to the problem here. So we have negative 3.26. So we know we have negative 3 on this outside number. Okay, the whole number is negative 3. Now we just have to figure out, what about the decimal? So what we do is we say, the way to say this is negative 3, and then this decimal we would say and. So the way to say this in words would be negative 3 and 26. You just say the number 26, and this last place is hundredths place, tenths place, hundredths place, thousandths place, 10,000ths, and so on. So this would be the hundredths place, so we would just put 26 over 100. Now I'm not done, because I can simplify this. So the way I simplify a fraction is by finding a common factor, so something that divides into both. Okay, so if we divide this by 2 and divide this by 2, I know they're both even numbers. I can't think of another one that goes into 26. So that would be 13. So that would be -3 and 13, not 12, 13 over 100 divided by 2 is 50. That is simplified. 13 is prime, and it does not go into 50. So that's the conversions. We need to remember how to... Okay, now let's just talk about fractions. Okay, fractions, again. One negative is negative, two negatives is positive. It's the same way with multiplication and division. But when we're talking about fractions, we need to remember how to multiply. So, and divide. But we're going to start with multiplication. So multiplication would be -1/3 times -2 3/4. Notice again, there's no adding and subtracting here in between these, so this is multiplication. We put two parentheses beside each other. That's the most mathematical way to do it. So the first thing we need to do is we need to recognize that we have two negative numbers, therefore our answer is going to be positive. So our answer will be positive. Now we're just going to set up this problem. 1/3 times, now I need to convert this. So 4 times 2 is 8, plus 3 is 11/4. And then we look in our corners. Now, is there a factor we can divide out there? No, 1 has only one factor of 1, and it doesn't do us any good. 4 divided by 1 is just 4. 3 and 11 also do not have a common factor, right? 11 has no factors, it's prime. So now we're ready to just multiply across. So this goes across and this goes across. Unlike adding and subtracting, I do not need a common denominator, okay? I just multiply across. Another way kids get confused is once they get used to multiplying across and then they go to add, they start wanting to add the two bottom numbers. Well, in adding and subtracting, if I have 1/6 plus 3/6, okay, once I have a common denominator, now I'm adding, I add 1 plus 3 and get 4, and I do not add the 6, it just stays sixths, okay? So that's another very common mistake. So again, multiplying, you do multiply across the bottom and the top. So 1 times 11 is 11, 3 times 4 is 12. We had two negative numbers here, so our answer stays positive. You don't have to write positive because positive is assumed without the positive, but we're done. Adding and subtracting, once we have this common denominator down here, it stays there. Okay, so we did not add across here. We did not add 6 plus 6 and get 12. So that's a common mistake. Once we get into this multiplication and division go across. Adding and subtracting is common denominator, and that denominator stays. So hopefully that, and obviously we could have simplified 4/6 to be 2/3. But moving on. All right, so what if we have, let's try another one. Let's do 4 1/2 times -3 1/3. Okay, so right off the bat we have one negative, so our answer will be negative because only one of these two numbers is negative. Now I do need to change these both to mixed number or to improper fractions. 2 times 4 is 8 plus 1 is 9, so we end up with 9/2. Notice you just keep the denominator. You 2 times 4 plus 1 and then keep the halves because we're going to stay in halves. 3 times 3 is 9 plus 1 is 10. So we end up with times, I will accept this as times 10 over 3. Okay, now we know they're one negative, so we know whatever we get over here, our answer is going to be negative, so I can go ahead and prepare my answer. I don't like putting my negatives in my actual multiplication because it just, I don't know, gets confusing. So now I'm going to look at my corners. Okay, 9 and 3 have the common factor of 3, right? 3 goes into 3. 3 divided by 3, right, would be 1. 9 divided by that same factor, 3, gives me 3. I can look in these two corners across from each other. And 2 goes into 10. So 2 divided by 2 is 1. 10 divided by 2 is 5. Now we can multiply across. 3 times 5 is 15. 1 times 1 is 1. So it would be negative 15 over 1, or anything over 1 is just that number. So it is just negative 15. So actually my final answer would have been negative 15. Okay. The good thing about multiplying and dividing, okay, so multiplying, dividing is the exact same thing as multiplication. It's actually pretty cool, except for keep, change, flip. So everything I just said about multiplication is the same with division, except before you start multiplying, you have to keep, change, flip. What does that mean? That means that if I have 2/3 divided by, and I'm going to use the division symbol here, divided by, because I want you to see the keep, change, flip easier, divided by 3. Sure. Okay. The first thing we do, obviously, is actually change this to 3 over 1, but then we keep the first number, change the division to multiplication, and flip the 3 over 1 to 1 over 3. I look at my corners. There's nothing I can factor out, so I end up with 2/9. Okay. And if 1 was negative, it would be negative, and if both of these numbers were negative, it would be positive. So just remember that. So multiplication and division is quite a bit easier. Okay, now let's talk about decimals. Okay, so decimals are, let's see. Okay, so let's say we have negative 2.5 divided by, or times, negative 3.6. Okay, so first of all, both of them are negative, so 2 negatives is positive. And now I want to put the number on top that has the most digits. So actually, let's change this just so you can see what I'm saying here. Let's change this to 3.61. Okay, so 3.61 not only is the larger value, but it actually has the most digits. So what I want to do is I want to pretend there is no decimal, and I'm just going to multiply. So I'm basically going to multiply 361 times 25, and I'm going to deal with the decimals later. So 5 times 1 is 5, 30, 18, and then I put a 0 here, and then I start multiplying again. 2 times 1 is 2, 2 times 6 is 12, 3 times 2 is 6, plus the 1 is 7. Then I add these up. Okay. And now I deal with the decimals. So I look at how many points are after the decimal point. Well, there's 1 on the bottom and 2 on the top, right? So I have 2 here and 1 here. So those added together would be 3. So I should move this over 3 places. 1, 2, 3. So the answer is 9.025. And now you want to check for check to see if it makes sense. And the way you would want to do that is you would want to say, okay, what is 3 times 2 is 6. This is a little more than half, and this is half. So let's just make 1 bigger. So 4 times 2 would be 8. So does it make sense that it's 9? Yes, it does, right? If I would have accidentally moved the place only 2 places, I would have ended up with 90. And I would have asked myself, is 3 times 2 anywhere near 90? No, right? So you could basically just multiply the whole numbers together and just make sure you're at least in the ballpark that you didn't move this wrong. Okay, so I expected a single digit number. 3 times 2 would be 6. Like I said, a little more than 6 would be 7 or 8. And I actually ended up with a little over 9, but that still makes sense. 90 would have not made sense. So if I messed up moving and only moved twice and got 90, checking for does this make sense would have saved me. So that's important as well. Okay, so dividing decimals is something like this, where we have, let's come up with a problem here. Negative 8.4 divided by 3.6. Okay, so on this one, we're just going to do first top trap. First top trap, FTT. So the top number goes in the trap. So we have 8.4 divided by 3.6. And the rule is that I can't have a decimal in my divisor. Okay, this is called the divisor. Okay, I can't have a decimal there. So what I do is I move the decimal 1 place to the right, and if I do that on this one, I have to also move this one to the right. So my new decimal is now here, okay, and then 36 goes into 84 2 times, okay, and then I highly recommend that you go ahead and on the side of your paper have a spot for scratch work, because we're going to do 36 times 2, and if you don't know that it's 72 right off the top of your head, you can figure this out. 3 times 2 is 12, carry the 1, and that'd be 72, right? 2 times 3 is 6, plus 1 is 72. So let's not get confused here. Go ahead and take the time to do this over here. It'll save you a lot of work, or save you a lot of mistakes. Okay, and then we end up with 2 and 1. And now we have to add a 0 here and bring it down. Okay, now 36 goes into 123 times. Let's check. 36 times, so we're putting 3 in. Sorry, my colors are getting all weird here. Times 3, which would be 18, carry the 1, 9, 10, 108. And we end up with 12. Okay, notice we ended up with 12 here, and we end up with 12 here. So that means that I'm going to bring down another 0, and I'm going to have 120 again, and I'm going to get another 3. So at this point, it repeats. So this right here is equal to, 1 negative is negative, 2 is positive, negative 2.3 repeating. So hopefully that all makes sense. You might want to watch this again. The biggest things you need to remember are 1 negative is negative, 2 is positive. With fractions, you're going to multiply across, but first you're going to factor out any numbers from the corners that you can. With division, you're going to use first top trap. The top number goes into the trap as well as the first number, and you just divide. So yeah, hopefully this was all helpful. You're welcome to ask me questions. I'm trying not to make this a 50-minute video. There's some other things to be learned in the chapter, like properties and things like that. You can look at your ebook or come see me about those, or if you're really struggling with them, I'll do a separate video. But I feel like this is hopefully enough for you guys to understand multiplying and dividing rational numbers. All right, we'll talk to you next time.